You know, when you think about a battlefield, you probably picture chaos, right? Smoke, noise, just sheer terror. But what if I told you that underneath all of that, there's often a cold, hard logic, a hidden mathematics that can actually decide who wins and who loses, long before anyone even fires a shot? And today, we are going to pull back the curtain on it. All right, check this out. On one side, you have the Battle of Crecy in 1346. We're talking English longbows against French knights in full-plate armor. On the other side, the Battle of Medenine, 1943. British anti-tank guns versus German panzers. I mean, these two fights are separated by almost 600 years. One is wood and steel, the other is high explosives. What could they possibly have in common? Well, that's the big secret we're going to unpack in this explainer. Because as totally different as these two battles seem, they're connected by a single, unchanging mathematical principle. It's a principle that tells us exactly why one side won and why the other was basically doomed from the get-go. So let's get into it. We can call this the combat calculator. And look, it's a simple formula, but it's incredibly powerful. It has the ability to explain centuries of warfare by just breaking down the total chaos of an attack into a few key variables, things we can actually measure and, believe it or not, predict. Okay, first up, you've got range. Now, this isn't just about how far a weapon can shoot. Think of it as the size of the killing zone, the deadly ground the attacker has to cross while everyone's shooting at them. The bigger that zone is, the bigger the advantage for the defender. Simple as that. Next up, attacker speed. This is a big one because it's all about how much time the enemy spends inside that killing zone. The slower they're moving, whether they're on foot, on horseback, or in a tank, the more chances the defender gets to open fire. Then, of course, there's the rate of fire. In that window of time when the attacker is vulnerable, how many shots can each defender get off? This is where technology really starts to matter, whether it's a medieval longbow or a modern machine gun. And last, but definitely not least, is effectiveness. I mean, let's be real, not every shot is going to hit. And not every shot that hits is going to take somebody out of the fight. This variable is a percentage that covers everything from accuracy to armor. It's really the probability that any single shot will actually do its job and disable an opponent. So, when you put it all together, it's actually a pretty simple but devastating chain of logic. You figure out the time, the attacker is a target. That tells you the rounds each weapon can fire. Multiply that by the number of weapons, you get your total fire. Then, you just apply the effectiveness rate, and boom, you get the predicted number of casualties. All right, enough theory. Let's see this thing in action. We're going to put the calculator to the test with our first case study, the legendary Battle of Crecy in 1346. This is that classic showdown, English longbows versus charging French knights. Right off the bat, you can see the English had a huge tech advantage. Their longbow had a max range of about 300 yards and could fire something like 6 arrows a minute. The crossbows the French were using, about half the range and a quarter of the rate of fire. The French knights were basically charging into a technologically superior weapon system. Okay, so let's start plugging in the numbers. First, the English had about 7,000 longbowmen dug in on a ridge, just waiting for the attack. Now, let's start crunching the numbers. The French knights had to charge uphill across a 300-yard killing zone. Estimates say that took about 90 seconds. With a rate of fire of 6 arrows a minute, that gave every single English archer enough time to let loose about 9 arrows. And this is where the numbers just get insane. 7,000 archers, each firing 9 arrows. That's 63,000 arrows raining down on a single French charge. We're talking about a literal storm of steel and wood. So what's the bottom line? Well, it's absolutely devastating. Even if you're conservative and say only 1 in 5 arrows actually hit a man or a horse, that's a 20% effectiveness rate. You're still looking at 12,600 potential casualties. The French were charging in waves of about 10,000. The math shows they were going to be shattered before they even got close to the English line. The attack was doomed from the start. Okay, so that was the 1300s. But does this math hold up? Let's jump forward 500 years to the American Civil War and the Battle of Fredericksburg. The weapons are different, but the math, it is exactly the same. When the Confederate General Longstreet saw the Union forces getting ready to attack, he famously told General Lee, "I will kill them all." He'd already done the math in his head. For the Union soldiers, the variables here are just brutal. They had to cross 400 yards of wide open ground to reach a stone wall that was just packed with 2,000 Confederate riflemen. It would take them about 4 minutes, 240 seconds to cross that field.
And in that time, each defender could fire about 12 rounds.
And when you do the math, it's just as brutal as Crecy. The Confederate defenders could inflict a potential 6,000 casualties on every single attacking wave. It was a mathematical slaughterhouse.
But here's the part that really turns this from math into a tragedy. Each Union attack wave only had between 1,000 and 1,500 men. They were sending soldiers into a field of fire that was mathematically guaranteed to wipe them out. They launched 14 separate attacks. Not a single soldier got within 100 feet of that wall. But okay, so far, we've been talking about defenders who are just stuck in one place. What happens when they can move? Well, this throws a really interesting twist into the formula, because it changes who controls that all-important variable, time in the firing zone.
Just look at the difference here. With a static defense, like the English at Crecy, the attacker controls the time in the zone by how fast they charge. But with a mobile defense, like the Parthian horse archers at the Battle of Carrhae, the defender controls it. They can just keep retreating, keeping the enemy at that perfect killing distance forever, never letting them get close.
You know who described this perfectly? Marco Polo, when he was talking about Mongol tactics. He wrote that they'd pretend to run away and then, quote, turn in the saddle and shoot hard and strong at the foe. They could keep their enemies in that killing zone for as long as they wanted, picking them apart with arrows before they finally wheeled around for the kill.
And look, this isn't just about knights and horse archers. This formula is just as deadly and just as relevant right through the 20th century and even today. Generals who get this math, they win. Generals who don't, well, they suffer catastrophic losses. So let's circle all the way back to that other battle we mentioned at the start, Medenine, 1943. You had well-positioned British anti-tank guns waiting for a German panzer attack. And those British gunners, they understood the math. They held their fire until the tanks got in close to maximize their effectiveness. And the result? Just look at this. It was devastating. The Germans lost 52 tanks. The British lost 0. There's a reason the famous tank ace Michael Whitman supposedly hated anti-tank guns. So for literally centuries, this fundamental math of range, speed, and firepower has ruled the battlefield. But that leaves us with one last big question. In an age of autonomous drones, hypersonic missiles, and AI-driven warfare, do generals even need to do the math anymore? Or has the calculator of war itself been changed forever?